Hello everyone, welcome to another video. Today we're going to have a look at what the graphs of exponential functions look like. So in particular, the graphs of y equals a to the power x, whatever a is. In the last video I talked about logs, and this is very, very similar here. And so I'm just going to jump straight into what the actual graph looks like. So let's have a think about that. Now, the key points here is when x is equal to 0. So when x is equal to 0, a to the power of 0 is equal to 1. And so we're always going to get the point 0, 1. No matter what the value of a is, it's always going to go through 0, 1. Also, when x is equal to 1, you're going to get y is equal to a. And so you're going to get another point here somewhere where if x is equal to 1, y is equal to a, just like we did with the logs. And just like we did with the logs, we can talk about what happens as x gets bigger and bigger and bigger. As x gets bigger and bigger, y gets astronomically big. So it gets huge. It goes up steeper and steeper and steeper as we go forward. What happens if a is less than 0? If x is less than 0. If x is less than 0, then we start getting square roots of fractions of a, and so that number just gets smaller and smaller as x gets bigger and bigger. Sorry, my brain not working today. As x gets smaller and smaller in a negative way, so bigger in a negative sense, I guess, then that number gets smaller and smaller and smaller. It never reaches 0, but it gets closer and closer to 0. So we get an asymptote coming up like that. So an asymptote at y equals 0. And that's what our function y equals a to the power x looks like. Always goes through those 2 points, and we get an asymptote there. The domain for this function will be all real values, and the range will be from 0 to infinity. And if you remember stuff about inverse functions, this is the inverse function of y equals log base a of x. And you'll see that it's the, if we put our do it through there, you remember that y equals ax looks like that, and so it's the perfect reflection in the line y equals x, and the range and domain have swapped over, so it's the inverse function of log ax, sorry. Good. So let's have a look at some quick sketching. I'm not going to spend heaps of time on this today. We already know how to apply transformations, and so this is just sort of a bit of have a look at what graphs look like. So I'm just going to jump straight into it. So here we go. So I've got y equals 4 e to the x plus 1. So straight away, so we can have a look at it. What's the original graph look like? The original graph looks like this. It goes through the point. Remember, it always goes through 0, 1, and it always goes through the point A. Remember, up here, it always goes through the point 1A. So up here, it goes through 1, E, okay, because here A is equal to E. So that's what the basic graph looks like when it's being times by 4. So remember, when we have a look at these, what happens? Let's just do it in dirt. So do your dilations first, then your reflections, and then your translations last when you're trying to look at this. So let's do that dilation here. That's a dilation. That's moving up from the x-axis. It's getting stretched up and down by a factor of 4. So let's do that first. What does that do to everything? Instead of 0, 1, that's going to become 0, 4. So it's going to go through at 4. And instead of 1e, it's going to be 1, 4e. Okay, so it's getting stretched out by a factor of 4. That's what the dilation is doing. And then the translation is moving everything up by 1. And so what will that look like? Well, instead of going through 4, it'll now go through 5. And instead of going through the point 1, 4e, it's going to go through the point 1, 4e plus 1. And that's what my final graph will look like. Also, we've also got this, I didn't draw it in there, I should have, but we also have this asymptote here, y equals 0. If that asymptote moves up, it's going to end up at y equals 1. So my final graph is going to look like y equals 1. It's going to go through the point 5. I'll just sort of stretch it down a little bit. It's going to come up like this and go up. I should have left myself more space. My apologies for that. So it's going to go through the point 0, 5. And it's going to go through the point 1, 4, E plus 1. And on your calculator, you could always figure out what that 4e plus 1 is equal to give you a bit of a better idea of what the graph will look like. But that's the whole graph. That's as easy as that. Okay. So, and then label it, of course, but I'm being a bit lazy here because I've got my messy pages and messy pen. So, so great. So that's how we deal with something like that. Let's have a look at another one. Let's have a look at this guy here. So y equals 3, take away x plus 3, e to the power 3x plus 3. And so I always just like rewriting this just to help my brain a little bit, because otherwise I make mistakes and I can't see it as clear. So I'm just going to write it like that. And it just helps me see the transformations a little bit easier. I can now clearly see, well, everything's going to get moved up by 3. Everything's going to get moved up by 3. It's going to be moved to the left by 3, and it's going to get flipped in the x-axis, so it's going to get flipped upside down. Again, let's just go through it in dirt. All right, so dirt again. So we want to do our dilations and reflections first, and then translations last. So we're going to do that plus 3 and minus 3 bit last, but let's do the reflection first, because that will affect everything that comes after it. Okay, so just very, very quickly, the graph e to the x looks like this, going through the points 0, 1, and through the point 1e. Again, up from here, it always goes through the point 1a. In this case, it's 1e. So it always goes through those 2 points. That's the original graph. If it does a reflection in the y-axis, what happens is that flips it upside down, so it's going to end up coming down like that. And instead of going through 0, 1, it'll go through 0, negative 1, and through the point 1, negative e. Okay, it flips that upside down. And then just a reminder that you've got your asymptote still at y equals 0. That doesn't change when it gets flipped upside down. And then we need to go to the left by 3. And sorry, to the left by 3, that's right. And then up by 3. So I'm just going to go straight to my final graph down here. So that asymptote is going to go up by 3, so it's going to end up y equals 3. And so everything goes up by 3. So I'm just going to change my y values here, because I'll sort of change those. And so that's going to become, instead of being negative 1, that'll become 2. Instead of negative e, that'll become negative e plus 2, or 2 minus e. Just adding, oh, I'm supposed to be adding 3. Did I add 3? Not to that last one. So it's going to be 3 take away e when I add 3 to that. And then it's going to be moving 3 spots to the left. And so that's going to become negative 3 by moving that spot 0 to the left. And that 1 is going to become negative 2. Okay. And so that's just moving everything to the left by 3. Did I do that? 1 minus 3, just checking all my things. Of course, you can check these things by putting things into equations and finding x-intercepts, y-intercepts. I'm just going to use some transformations here to find out what the final thing looks like. So we've got y equals 3 coming through. This is going to sort of come through there. And so we've got the point negative 3 and 2. So negative 3 and 2. So somewhere up here. Negative 3 and 2, and the point negative 2, 3 minus e, which will be sort of like something like there. So it's going to come up here through those points and continue down like that. We've got y equals 3. I'll just put more points on there. So what was it? Negative 3 and 2. And this point here, negative 2. It's not accurate, but you get the idea, and that's terrible. I'm going to run out of space there. Negative 2. 3 for that point there. I haven't calculated x-intercepts here. Here in this particular graph, x-intercepts and y-intercepts would be probably the best way to graph this. You could just get an idea of what shape the graph is, because you know it's going to be y equals 3. It's going to dip down here. You could find the x-intercept and the y-intercept by subbing in x equals 0 and y equals 0. That's probably a better way to sketch this one in particular, rather than using transformations. But there's always more than one way to skin a cat. Hope that makes sense. See you in the next video.